Hello, this is East Coast Tinker here. In today's project we are going to make a Bedini circuit with a 2N3904 transistor. And here it is. It's a small transistor, but it's adequate to run a snake-edged Bedini or a fluxfield generator. For this project you're going to need lots of parts, and we will go over them as the video progresses. For now, all we need is a strip of wood. The dimensions here can be anything. You can have it as long as you want or as wide as you want. I've just chosen these dimensions, but you're not limited to this design. But what you will need is a European strip that you can get from Radio Shack. They're the audio connectors, which use the flathead screwdrivers to clamp down the wires, since we're not going to be doing any soldering in this video. Once you get your piece of wood, you can label depending on how this transistor is placed in. This here is the round part is facing up, the flat side is down on the board. So with the corresponding holes, you will have C for your collector, B is your base, and E is your emitter. And for over here, these are where your coil ends will go in. You have your start and your end, and you have your trigger, power, trigger, power. I neglected to mention how the audio strip is connected to the board. I'm using double-sided adhesive tape to do that. And for the next section, I have just placed in my diode. It is a 1N4001, and I have the gray stripe pointing toward the base, so it goes from emitter to base, gray stripe going to base. That is your next step. I've just installed my next diode, which is a 1N4007. That is the rectifying diode for charging the battery. As you can see, it is going from the collector to the next junction point past the collector junction. So it's this one right there, and the gray stripe is facing this junction. That is our next step. I have chosen to use a 1000 ohm resistor, and as you can see, I have one end going into the base and the other end going into this junction right after the emitter. I just installed a 9-volt battery connector that will serve as the connection point to the charging battery. The positive line runs and goes in where the 007 diode connects to the second junction right after the collector, and the negative line goes into the adjacent junction point here. I've installed the second 9-volt battery connection, the positive going from the same junction where the negative of the charge battery goes, and the negative line goes to the last junction point on this side of the strip. This 9-volt battery connection will be your source battery. Run a jumper wire from the adjacent junction port from where you put the negative line from your run battery. Run the jumper wire from there down, follow my thumb, into this port or junction port here, which is, I believe, your emitter. Now run another wire from the same junction point here, following my thumb, run the line all the way down to where our coils are going to be connected. This one here is going to this connection point on top, which will be the trigger coil of the start of the coil. So again, follow my thumb from here all the way down into that junction point. Now we're running a wire from this junction point, which is the second from the top, prior to the one we just worked on. Run a wire, follow my thumb here, all the way down to this junction point, which is going to be the end of coil, and it's going to be the power. Now run a wire from the junction point, second from the bottom here, follow my thumb, into this junction point, which is the end trigger. Okay, the last coil wire to be connected comes out of the collector junction point, which is right here, and follow my thumb. It's running down and into this junction point right here, and that would be your start power. Okay, this is a very simplified Bedini circuit. You can make one with a potentiometer and a neon bulb for protection in case your charge battery isn't hooked up correctly, or just not hooked up at all. Basically, that neon bulb is just a fail-safe to keep this transistor from overheating and frying. But I find that with this particular circuit, it's not necessary. The transistor really doesn't overheat as long as you don't exceed 4 AA batteries. Anything over that, doesn't matter what kind of safety devices you put on there, it's going to fry. So don't even bother going over 4 volts. I've already tried it, done it, it won't work. So, but putting the neon in is kind of a waste because it never achieves enough voltage to actually turn it on. So chances are you're going to want to leave that out of the circuit. But if you did want to install it, the install junctions would be your collector and emitter. That's where you would place those two to get that. Oh, and if you wanted a potentiometer, the best place would probably be to put it right there and just have the line coming off of the resistor, which is this junction point. So off of here, just have it going into your middle wiper on the potentiometer, and have it coming off either the right or left wiper to complete the circuit going into, let's see if it travels here, to this junction point. Okay, I have my unit ready to go. I have my 4 AA nickel metal hydrides ready connected, and I have a rotor here. It's a 1/2 inch neosphere inside of a bifilar coil. Give it a spin. There we go. Okay, we're back. First thing I want to say is that I replaced the transistor on this circuit. I am now using a 4401. Moving on, here is another type of rotor I'm using. This one here is just a wooden dowel with a ring magnet, and placed on that ring magnet is 2 block magnets and a button neos stuck on top of that. These magnets are not glued onto the ring magnet. They are just held by magnetism. I find that the rotor isn't revolving fast enough to send those magnets flying. Lid Motor had mentioned in one of his videos about how sufficient weight and inertia plays a big factor in the rotation of these rotors, and he is absolutely right. Once I added those Neo buttons on there, this rotor really improved. Okay, I've now replaced my 4-pack with a 2-pack here with 2 nickel metal hydrides, and over here on this section I have replaced my rotor with the fluxfield generator, and we'll try to do this left-handed. Oh, fooled me, almost did it. There we go. There we go, fluxfield generator being run by the circuit we've just done. There we go with a snake egg Bedini. Just took a second to get it to run. It's a little wobbly, but it is running. It's I don't know if the batteries are getting low or what, but this is usually not the platform I run it on. I have another. It's starting to improve. I think over time it's gaining in RPMs, but this is the last rotor design that will work with this particular circuit. Anything more elaborate, you'll have to go to a higher capacity transistor like a tip 3055 or the 2N3055 transistor.